Hello students, welcome to engineering assignments. In engineering assignments, we are going to study a subject called as machine learning. In that we are going to discuss a topic called as basis of parameter estimation. Before studying parameter estimation, you should have thorough knowledge about probability distribution that you are studying in your engineering mathematics. You should have knowledge about Bernoulli's distribution, Poisson's distribution, exponential distribution, normal or Gaussian's distribution. Then only you can study this particular topic. Now we are going to start parameter estimation. It can be done using maximum likelihood estimation, maximum posterior estimation and Bayesian's formulation. And maximum likelihood estimation is short form is MLE and maximum posterior estimation is written as MAP. Now what is this parameter estimation? Parameter estimation estimates a parameter of a given distribution theta values that explains the observation x. I'll give you a certain examples based on it. You look here, you have a normal distribution. The normal distribution, the probability density function f of x is equal to 1 divided by sigma root of 2 pi e raised to minus half x minus mu divided by sigma the whole square. Okay, so this equation, you should know this equation and you might have studied from your engineering mathematics. For this equation, finding out mu and sigma is called as parameter estimation, and these parameters will suit well to your model. Moreover, parametric estimation calculates the probability of new observation for a given data. So, in parametric modeling, the first thing which is done is estimate the parameters from a given sample, plug them in assumed model to get estimated distribution, and use this distribution to make the decision. I'll give you one more example of parameter estimation. Let us consider some green dots over here and we have some pink dots over here. Now, to classify the green and pink dots, we can draw a hypothesis of a line. Okay. You can draw one line like this. Let us mark it as H1 hypothesis. You can draw another line like this to classify them. We can write it as H2. Next, you can draw a line like this also. You can write it as H3. So here I have drawn three hypotheses to classify the green as well as the pink dots. Okay. Now, what is the equation of each hypothesis? Here you will have y is equal to mx plus b. Here also you can write this hypothesis as y is equal to mx plus b. Here also you have the hypothesis equation as mx plus b because it is a straight line. Now here the m and b are the parameters. Here also the m and b are the parameters. Here also the m and b are the parameters. Now we have to estimate the parameters m and b in such a way that it will correctly classify the data. So students, I hope that you might have got some knowledge about the parameter estimation. Now you can see a figure which is given here. The figure states that a sample data is taken from a distribution, then the parameter is estimated and fitted into the model for decision making. So students, I believe that you might have got some knowledge about what is parameter estimation. Now let us discuss what is maximum likelihood estimation, and the short form is MLE. Maximum likelihood estimation MLE is a method of estimating the parameters. So you have already got an understanding about what is parameters. So it is dealing with estimation of the parameters of an assumed probability distribution given some observed data. This I have already told in the introduction part. Now we can say that the probability of a data given the parameter is commonly referred to as likelihood. And what this MLE does is that MLE attempts to find the value that maximizes the likelihood function given the observation. The resulting estimate is called as maximum likelihood estimate. Now, what does MLE tries? The MLE tries to find the estimate of the parameter theta. Theta consists of all the parameters in it by maximizing the likelihood function. Now I will tell you in detail the steps which is taken for maximizing likelihood. Assume that we have independent and identical distributed random samples. So independent and identically distributed, in short form we will write it as IID. Random samples X having x1 to xn, which is taken from probability distribution having a probability density function p x given theta, which depends upon the unknown parameter theta, and theta we can say that is a set of parameter that appears in the function. And what is this x? X is actually the value of the random variable. Okay, now let us see how it is done step by step. First one is to construct a likelihood function. According to Bayes' formula, P of theta given x is equal to P of x given theta into P of theta by P of x. Now here in this equation, this part is called as likelihood of the theta. So when we construct the likelihood function L theta given x, you can write it as P x1 till xn given theta. In some textbook it will be written as like bar, and some textbook it will be written as semicolon. Okay, same thing. So according to the Bayes theorem, L theta given x will be same as P x given theta. Now next is we use the property of IID random sample to break the joint the probability density function, the short form of probability density function, to the product of n marginal probability density function. So we can write it as P x1 till xn given theta equal to pi I is equal to 1 to n P of xi given theta. This pi represents the multiplication. So to make you understand better, I am writing like this: L theta given x is equal to P of x1 given theta into P of x2 given theta into till you have P of xn given theta. This is the same thing what is written over here, and this pi represents multiplication of them. And we know that the multiplication is very difficult to perform and a very tedious process. So what we can do here is we take a log, usually natural log, to change the product to summation, and this does not change the optimal estimator since logarithm is monotonic function. So we can write that is L x given theta to, see, it is in some textbook it will be written as the bar, and some textbook it will be written as semicolon. So it's the same thing. Okay, whichever way you want to write, you can write. So here what we can do is that we give logarithm, that is we apply log at both the places, that is here also as well as here also. And if you apply log, then L theta given x represents log likelihood function. And in the next step, differentiation is applied to this log function, and it is done with respect to theta. Okay, as well as it will be set to 0. Therefore, it is written like this. Finally, the estimator will only be a function of the observed data, and you will get the maximum likelihood, and this maximum likelihood is represented by theta cap ml, which is equal to g of x1 till xn, and this is how it is done. Okay, for getting better understanding about the topic, we will be doing one problem in the next video. So students, thank you, and thank you for watching my video.